if you're not going to give an effort in this class, you're going to be in trouble. A lot of you didn't study for that test. I don't know what you were thinking. But man, you got to study. You got to hang in there and work hard. I wish I had time, because really I just tell you the story of Raina, and you guys know who Raina is. Came here from public school. They put her in dummy math and they passed her along. Said she can't learn math. We're just going to pass her along. We don't care what she does. She can't do math. We're just going to pass her. And that's what they did. Pass her. Then she ended up here in Algebra 1, and she was like, whoa, what am I going to do? And she was getting 30s and 20s. But then she decided, well, I'm going to try. And so she went all through Algebra 1, fine. Started getting B's and stuff in Algebra 2, B's. You know what the difference was? She worked at it. I'm just telling you, it's, for all of you, that's the answer. Now, again, you can say, well, I'm just not math material. Okay, you may not be math material, get an A. But you should be able to get a B or a C. I'm just telling you. You can. And the reality is you. So get some toughness, get some grit, get some desire. Problem is, you don't want it. And if you don't want it, then you're not going to get it. So, all right, that was free. This is all review today again. So again, those of you that you're not great in this area, these are review topics. So again, we're going a little fast here. Might need to go back, watch the video. I hope you're reading the lessons, each lesson, like I told you at the beginning of the year. I dare say if I polled you, everyone almost would say, no, I don't read the lessons. Okay, these are things that are going to help you. But you didn't assign it, so I don't have to do it. Yeah, okay. No, if you don't want to learn anything, I can't help you, all right? I can't help you. All right, the graph of a linear function, if you remember, is right there in the word linear. It's a line. Linear functions are lines. Pretty simplistic. And so we got 3 of them there. 3 different lines. 2 important points along the lines are the intercepts. The intercepts. Okay, so the x-intercept is also called a 0. Because guess what? The y value is 0. So let's circle the x-intercepts, right? Let's go to the 3 lines up above. Let's circle the x-intercepts. Okay, how about right there, right? What are the coordinates of this point? 2, 0. See, the y value is 0. Go ahead and do the second one, right? Coordinates, -5, 0. Right, the y value is 0. Third one, right there. And that one actually, probably right there now that I look at it. Oh no, I have to guess. Looks like about -2.5 to me, and I am guessing. And 0, right? That one looks like a little bit between. Y-intercepts, notice, x-intercepts, notice each one, the x value is 0. Okay, so look at the next line. How would you find the x-intercept mathematically? Well, if the y is always 0, then guess what? Put 0 in for the y and solve for the x. So look, here's the thing. You got an equation with x and y. You want to find the x-intercept, put a 0 where the y is and solve for x. Pretty easy. You're mathematically finding the point where it crosses the x-axis. And we can do the exact same thing with the y-intercept. So see, the y-intercept is the y value when x equals 0. So let's go with our green. Let's go back to our graphs and let's do the y-intercepts. There's one right there, right? Coordinates of that point, 0, 3. Notice the x is 0, right? Again, 4-color pen really helps keep things color-coded. This one, Where does that line cross the y-axis? Again, by the way, if you're not understanding, the vertical axis is the y, and I assume that was basic knowledge. Let me not assume anything. The horizontal is the x. So the second one, what are the coordinates? 0, 2. And the third one, what are the coordinates? 0, 1. Right? Y-intercept. The y value and the x is 0. So how do you find it mathematically? You don't want to take time to graph it. You don't need to graph it. You got an equation. What do? Sub in 0 for the x, solve for y. Okay? And again, it's easy because you're looking for y. So you don't want to get rid of y. You want to get rid of x. Put the 0 in for the x. When you want the x-intercept, you want x. You don't want y, so put the 0 in for y, you get x. Pretty easy. Just put in 0 for the x or y and solve. Voila! You are there. All right? So x and y intercepts. So here, mathematically, find the x and y intercepts. Okay. So I'm going to do it on the board, but if you already got a grasp on what's going on, go ahead and find the x-intercept. Go ahead and find the y-intercept. If you need to look up to get some help, then look up. If you can do it yourself, then do it yourself. Right? The x-intercept is 4, and the y-intercept is -8/3. What if they asked you for the coordinates? Well, not a problem. That one is 4, 0, right? And this one is 0, -8/3, right? If they ask you for the coordinates of the x-intercept and the coordinates of the y-intercept. Again, every x-intercept has an x-coordinate 0. Every y-intercept has an x-coordinate 0. All right, I may have said that backwards, but you got the idea. Linear functions. Remember, they're lines. Word line is right there in linear. Can be graphed using the x and y-intercepts. So that you can graph a linear function with finding the x-intercept and the y-intercept. You plot those 2 points and you draw a line through them. So go ahead one more time, figure out the x-intercept, figure out the y-intercept, plot those points on your graph, and draw a line through them. Again, if you need help, look up, and I'll be doing them as you're doing them. Always arrows on both ends, because remember, that line goes on forever and ever. By the way, lines, real easy. Watch. Domain, -infinity to +infinity. Range goes all the way down, -infinity to +infinity. Lines, almost always, unless a special case, are both all the real numbers, all the real numbers. All right, slope. Do you remember slope? I hope so. All right. Slope is the ratio of rise to run. Roofers talk about rise and run. Plumbers talk about rise and run, or pitch, same thing. But what is the rise? So I'm going to go in the blue box now, and it's the change in y, and a triangle symbol means changing. So we say delta y. That's a delta symbol. I think it's Greek. It means change in. So the change in y, right? The vertical change, right? Rise is vertical, right? Run is the horizontal change, so change in x. So ultimately then, do you remember the formula? So it's m equals, right? What's the vertical change? Y sub 2 minus y sub 1. Those are not exponents, they're subscripts, right? Y sub 2 minus y sub 1. You guys remember what that means? Yeah, the y coordinate of point 2 is y sub 2, and the y coordinate of point 1 is y sub 1. What if we don't know which point to call 1 and 2? Does it matter? No, it doesn't matter. And so the bottom is going to be x sub 2 minus x sub 1, right? And that will allow you to find the slope of any line. Now don't forget, the top is the vertical, up or down. So a positive top says go up, but a negative top says go down. If there happens to be if there's no sign in the bottom, it's positive and it's right. Positive is right horizontally, right? Bottom's horizontal, right is positive. If there happens to be a negative in the denominator, then it's left. Usually there's not. Usually it's just one negative sign, but it's possible. All right, so up, down, left, right. Okay, so let's do a couple here. Get rid of this. Whoops, I didn't want to get rid of that. Oh well, that's fine. That'll work. I won't go too high. So A, let's first deal with positive slopes. Positive slopes. A positive slope, listen now, this is the key. The output, is that the x's or the y's? The range, is that the x's or the y's? The y's. When you were doing ranges, you were going from low to high, correct? So you were going from bottom up. When we look at a positive slope, as we move from left to right, we want to see if the output is getting bigger. Is the y value going up from left to right? So here's what I mean. If you look at the little graph right here, right? So this is what I mean. Let's start at this left point. What's the y value? 0. Here, what's the y value? 1. Here, see we're going left to right. What's happening to y? See how it's getting bigger? Now it's 3. We're still going left to right. Now it's up to 4. You see how you work? Left to right, what is the y doing? It's getting bigger and bigger and bigger. That is a positive slope. So basically, if you look at it, it's going to go up from left to right. And doesn't that line go up from left to right? It's a positive slope. So negative slope is going to be just the opposite, right? If this was a graph of your money, you don't want the second one because you're going into debt. All right, credit card debt, I guess. And these, they're going to go down from left to right. Notice as you increase the x's, what happens to the y? It gets lower and lower, and lower and lower, and lower and lower, negative slope. And mathematically, it's negative as well. So let me go back to the left one. What's our vertical change? Positive 4, right? What's our horizontal change? Positive 3. What's a positive divided by a positive? A positive. It's a positive slope, right? Take any 2 points, figure out how much you change vertically. I got to go up 4 to get to this point, and I got to go right 3 to get to that point. Up is positive, right is positive. Look at this second one. From this point, I got to go down 3. Down is negative. So now my vertical change is negative 3. And I got to go right 2, and right is positive. And what's a negative divided by a positive? A negative. It's a negative slope. Positive slopes go up to the right. Negative slopes go down to the right. Positive slopes go up to the right, negative down. Any questions on those two concepts? That's review, I know, but I don't want to assume anything. Okay. Then how about a couple special scenarios? How about a horizontal line? What's the slope? Do you remember the slope of a horizontal line? How much slope does that have? 0, right? It's a 0 slope. What's the rise? What's the change in y of a horizontal line? 0, right? There's no change. Do you agree? So wouldn't it be 0 divided by whatever run you have? And what's 0 divided by anything? 0. So it's a 0 slope. Horizontal lines don't have any slope, right? 0 means none. You don't ski. You don't go to ski. You don't pay $100 to ski on a slope like that. It's really boring. You pay to get killed skiing a slope like this. All right. Vertical lines. Vertical line. Anybody remember the slope of a vertical line? Okay, let me do the thing again. I don't see this on the video, but that's okay. All right, so a horizontal line, right? What's the value of the slope? 0. Tell me if the slope's getting bigger or smaller. Bigger. 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 What is that?
Biggest.
Biggest. And what number is biggest?
Infinity.
It is infinity, right? So you got an infinite slope. Because what is the horizontal change of a vertical line? 0, and what's division by 0? Infinity, right? Remember me in algebra or pre-algebra standing at the door chucking nothing into the room? When can I stop? Never, because I can chuck an infinite amount of nothing. I'll never fill it up. Right? Again, the purists want to say undefined. So we will throw that in because they don't think you can handle infinity. So we'll put a U there for undefined. And I'll put it down here, or undefined. And that's again because usually in division, you can undo the division by multiplication, get back to the divisor, to the dividend. But you can't with infinity, and so the purists say no. But look, biggest is infinity. Anything divided by 0 is infinity. The answer is infinity. All right? So, use the slope formula to find the slope of the points 2, -3, and -5, 6. Okay. Here's what I taught you guys in Algebra 1, and I would advise you to still do this. Just take a second and label the points, the coordinates. That's x coordinate of point 1, so that's x sub 1. And the -3 is the y coordinate of point 1, y sub 1. Because you can't get that confused, and if you label it, just takes a second. You're not going to miss it. -5 is the x coordinate of point 1, point 2, I'm sorry, and 6 is the y coordinate point 2. That's just going to help me when I sub in. Okay, so normally you're going to have the formula. So let's write the formula again. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Is the wise Algebra 2 student going to write their formula each time if they want to remember it? If you already have it memorized, I'm okay with that. But let's stick in the values. So now you're just looking at what you labeled, right? What is y sub 2? It's a 6. Now everybody pay attention here. Notice this blue negative of the formula, right? And then what is y sub 1? -3. Be careful with that minus and minus. Students mess that up. So the minus from the formula, then the minus from the 3. All right, x sub 2 is -5 minus x sub 1 is a 2. So where do we end up with? 9 over -7, right? Do we leave negatives in the bottom? Numerically, it's the same, but we usually put it in the top. So I know this line goes down to the right, and for every 9 down, you have to go right 7 to hit the line. 9 down, right 7, 9 down, right 7, 9 down, right 7, 9 down, right 7, 9 down, right 7. All right, do you remember slope-intercept form? I tried to burn this in your brain. I had a question on every single test once we learned this in like chapter 3. So every single test had questions on it with slope-intercept form. So I'm hoping you still remember it's y equals. Awesome. You guys are amazing. First time in 2 years you had to say that and you remembered it. Great. Y equals mx plus b. Okay. Look at our example. Look at our graph right here, right? Can you tell me the y-intercept? Right? The y-intercept is -3. Do you agree with Justin? So where the plus b is, I'm in green going to put a -3. Makes sense? Because isn't that the y-intercept, right? This right here is the y-intercept, right? I'm just throwing in y equals mx plus b. And let's figure out the slope. All right, so everybody watch the screen. I'm going to start at -3, a point I know. And I'm going to go up. I'm going to see how far I got to go up to get to that other point. 1, 2, 3, 4. 1, 2, 3, 4, 5. I went up 5. Do you agree? So the top of my fraction is 5, right? The vertical change. And now I take my red, and what do? I go to the left, or to the right, I'm sorry, 1, 2. So I go right 2. What is our slope? 5/2. And we have now the equation of that line. Y equals 5/2 x minus 3. It's the equation of that line. Again, we've done all this in Algebra 1, but we're trying to refresh our memories, knock out the cobwebs. Vertical change, remember, up is positive, down is negative. To get to the left, right, left is negative, right is positive. All right. So let's determine the slope and the y-intercept of each and graph it. And I'm going to abbreviate y-inter for time. Determine the slope and y-intercept of each and graph it. Okay, I'm color-coded. So class, what's the value of the slope? 2/3. So I'm going to come over here, I'm going to write 2/3. On the 2, do I go up, down, left, or right? 2. Up, because the top is up, down. So for the 3, do I go up, down, left, or right? Right. And again, talk, participate, it'll help you remember. So right 3. All right, say that. We're going to use it in a moment. What's the y-intercept? 1. And if we want it in coordinate form, then it's going to be 0, 1, right? Because the x is always 0. Okay, big key. You got to do this first, right? This is how you start if you graph from y equals mx plus b, right? You always graph the y-intercept first. So go to 0, 1 and put your dot there, and I'm going to draw an arrow to it, right? And now do you remember from there, use your slope, right? And so what am I doing? I'm going up 2. So I just drew an arrow to show me going up 2, right? And now I'm going right 3. 1, 2, 3. And there's my second point. Any 2 points determine a line. Draw your line through those 2 points. There's your line. And if I had a little more time, I'd show you how that slope is the same everywhere. Because it is. Slope is the same all along the line. All along the line. By the way, could I go down 2 into the left 3 and hit the line? Because isn't a negative divided by a negative a positive? Don't write this in your notes, but look. Let's go down 2 and to the left 3. Oh, look at that. Hit the line. Right? And if I go down another 2 and to the left 3, guess what? I hit the line again, right? And if I go up 2 and to the right 3, guess what? I hit the line again because the slope is 2 toids. All right. Put the following into slope-intercept form, then determine M or B. So you get a problem like this where it's not ready for you yet. This is why we learned how to solve literal equations, and also for physics down the road when you get it. But we need to solve this equation for what variable? Y, right? Because isn't slope-intercept form y equals mx plus b? All right, so look, we moved the 3x. That's not a problem. I'll show the step. I'll add a negative 3x to both sides. You don't need to show this step. This is Algebra 2. All right? I'm just showing it for clarity's sake. So now we got negative 2y equals negative 3x plus 6. Put your x in the front. It's always easier. All right, let me show you the easy way how to finish. Divide everything by the negative 2. That's the easiest way to finish this thing off. Just divide everything by the negative 2. So now what do we have? Y equals 3/2 x minus 3. Do you agree? Just remember to divide everything by this coefficient. Again, it's the same as multiplying both sides by 1 over negative 2 or completely dividing both sides by negative 2. But we're saving a step. And by the way, we want it separate anyhow, right? Because you want the slope, you want the y-intercept. Okay, so what's the slope? 3/2, right? And again, up is positive is up, and positive is right. B value is clear. It's negative 3, or if you want coordinates, 0, negative 3. All right, we don't have time to finish this one, but you could do it right. You would do the y-intercept first, and then from there you'd do the slope, right? Everybody okay with that? Getting the cobwebs out. Tim, have you done any graphing in your Algebra 1 with lines? Okay. All right. To find the slope of a graph line, look for 2 clear points. Look for 2 clear points. So what I mean is definitely see where the line hits in it. So look, isn't this one a clear point right there? Isn't that a clear point? And I don't see another one until here. Do you agree? Look on your paper. Find where the blue line hits right at the intersection, right? Isn't that the 2 spots? Okay. So to get from this left one to the right one, how much do we go down? 1, 2, 3, 4, 5, 6, 7 down, right? Did we just go down 7? And down is positive or negative? Negative. Probably should have done that in green, huh? I'm out of my color element. So negative 7, should have done that in green. Dummy. And then from there, how far right do you go? 1, 2, 3. That's a positive 3. And voila, we've got the slope. And by the way, we don't know the y-intercept. We'd have to interpolate that. That's a whole other story. That's all we want to do at this point. Okay? All right, pretty easy, right? 2 clear points. You can read your slope. Hey, 39 and 41, no original. There's either a graph or a bunch of words, and I'm saving you time. I'll do that throughout. You'll see that in your notes that I say. After this, I'll say like N.O. right? No original. Okay? That's what that means. You don't have to worry about the original problem. Hey, come on. Let's have a better chapter 2. I'm telling you, you can do it. But look, if you don't change, what's the definition of insanity?
Trying the same thing over and expecting different.
Yeah, exactly. Doing the same thing over again and expect different results. Not going to happen. Change. You can. You can do it. Do it.